Students, today we will be actually looking into your first experiment, which is nothing but your spectrum analyzer. And we will look as to what are the uses of it and how we are going to take the best use of the spectrum analyzer. The model is RSA306. So just give me a moment as we get started with the presentation. Okay, so this is going to be your code for your lab, which is ECE 71. It is your wireless and mobile communication lab. And this is going to be your first experiment, study of basic operation of spectrum analyzer. Okay, now what is the aim of this program? It is nothing but to study the basic operation, okay, of a spectrum analyzer and analyze various parameters of FM signal. Now FM signal is nothing but your frequency modulated signal, and we will just look into few details involved and what is exactly needed for the operation. Okay, and this is used for viewing RF signals in frequency domain. It converts time domain signals into frequency domain for display and analysis. Now this is very important. Now even in our cell phones we do have FM signals, right? But we cannot do any analysis. So using this device, okay, we will be able to analyze and we will be able to check as to how these signals are responding, what is going to be the delay and the related parameters. Spectrum analyzer displays power levels with accuracy of approximately about 0.5 decibels. Okay. Now I have just put up here for your reference, okay, and a small match the following to be done here with regards to measurement categories and what kind of instrument we are using to measure the same. Okay, we have power, frequency, spectrum, transmission, uh, then we have time characteristics, then modulation characteristics. Towards the right hand side, what kind of instrument you are going to use. Okay, so of course for our spectrum we are going to use spectrum analyzer, right? So we will see this matched up in the upcoming slide. So your power can be measured using power meter, then frequency can be using your frequency counter, spectrum can be measured using spectrum analyzer, then your transmission can be analyzed using network analyzer, then time characteristics using oscilloscope, and your modulation characteristics using modulation analyzer. So before we get started, I want you to just have a look at these waveforms. Okay, these are different types of waveforms which can actually go high and low. These are complex signals with respect to time and amplitude. So we can measure the power. Okay, so if we can see the signals in time axis and frequency axis, this is how, if we actually distribute these signals in a different level, okay, so this is how you will be able to see. Fine, this I have just put up for your reference where you can actually see as to how these signals, okay, these signals when you see from front view how it is, and when you see the signals from the side view, how it looks. Okay, so then different categories here, right, with respect to frequency, time, and amplitude, right? So let's just look at them and let's try and understand as to how we can go about with the experiment. The frequency versus level, this is done using spectrum analyzer. Normally it is taken up with frequency domain, and your level, which is amplitude, okay, the height of the signal is corresponding to time versus level, okay, and this is done using your oscilloscope And the domain that is going to be used here is time domain. As we know, there is frequency domain, time domain, right, and modulation domain. So here, okay, in between frequency and time, okay, that's what you can see the arrow mark here, frequency and time. So you have frequency versus time. So this is for your modulation analyzer, and this is done using your modulation domain. So just a brief introduction as to what is time domain, frequency domain, and modulation domain. So time, as we all know, it changes with respect to t. So t naught being the initial point, t naught, t1, t2, t3. So it goes on. So time, the signal changes with respect to time. If a signal has many frequency elements, the analysis is very difficult. So that is one downside of time domain. Next, with respect to frequency domain, each element of a complex signal can be separated easily because they are not bound to time, they are bound to only frequency. So if I know the frequency of a signal, according to the frequency, I can separate different signals. So that's how we use filters. We design filters wherein the frequency of interest can only be obtained or can be rejected. Low-level distortion signals can be detected, and spurious elements can be measured. So this is one parameter that we can think of. Modulation domain, changes in frequency can be seen, okay, and modulation accuracy can be analyzed. Changes in amplitude cannot be seen. Here in modulation, whatever is the signal level, the height of the signal cannot be seen, but rest of the things, such as the changes in frequency, if it's low shifting to a lower frequency or it's shifting to a higher frequency, all these can be actually seen. So these are some examples of your time domain signals, okay, time domain and frequency domain and modulation domain, so that you get an idea as to what these signals are. Okay, so these are your continuous waveforms, your frequency modulated signal, and your amplitude modulated signal. So these are modulated with respect to frequency. So as the frequency goes high, the signal comes too close, and with your amplitude modulation, you can see that there is a change in height of the signal with respect to time. All these are with respect to time. Next, frequency domain, as you can see, okay, you can see that as the frequency increases, they come close to each other, and these are the levels of signals. Similarly, your modulation domain signals. So let's move on to the next one, which is a very important slide for our experiment, okay, which is the block diagram. So you have an input signal here, and then it has an RF input attenuator. It has to pass through a filter. As I told you, filter is designed based on what kind of signals we are interested in. So if the signals, okay, that I am interested is of higher bandwidth, then I'll have to design my filter in such a way that it can analyze those signals and take out or filter out only those signals. Then these are passed out to something called mixer, and mixer has another input called local oscillator. Okay, so we need a local oscillator. So this combines, okay, and it is again moving on to another section called IF gain, and this is again your attenuator that you see after your IF gain. So attenuator is used for uh, getting the signals degraded. Then you have your IF filter, okay, intermediate frequency filter, then your logarithmic amplifier. Then we have an envelope detector, which will actually take only the outline of your waveform. Then all these are actually given as input to your video filter. Now, in order to see the signals, I do not have any option. So what I will do is I will connect it to a monitor. Okay, once I connect it to the monitor, then I will be able to see these signals, right? So this is your entire block diagram of your spectrum analyzer. So right from input signal to viewing the signals, it has a lot of filters, and then it has envelope detectors, and then it has amplifiers. Now getting on to some basic information with regards to your spectrum analyzer. As I mentioned previously, your spectrum analyzer model's name is RSA 306, right? So your RSA is nothing but your real-time spectrum analyzer, and the model number is 306. And it is actually capable of measuring from 9 kilohertz to 6.2 gigahertz, which is a high range of frequency that can be analyzed, right? And it has levels of dBm from plus 20 to minus 160. Some of the key features that I've pointed out here is it can handle about 27 spectrum and signal analysis measurements standards. So if you can see, this device can handle a lot of measurement parameters. So I will be showing that in the tool, and you will be able to understand in a much better way. Options for mapping, modulation analysis, Bluetooth, WLAN standards, all these can be supported. All these are supported. Then real-time spectrum or display to minimize time taken on transient and interference hunting. So these are some of the features. So you have a display, okay, you have an interference where you can actually check exactly as to what's happening in real time. You can stop a signal and you can analyze as to how can I improve the signal. Basically, communication is all about the signal being transferred or communicated without loss from the source to the destination. Then we have APIs, which is application programming interface, included for Microsoft Windows environments. Okay, so this is about your software. Then you have your toolbox integrated with MATLAB. Some of the applications that we will be using is with regards to academics, which is currently what we are doing, right, for the purpose of education. Then we have maintenance, installation, and repair in the factory or field. So these are, some of the things that I had thought of in sharing with all of you before we get started with the experiment. So this will be the formula used for the calculation of amplitude versus frequency, which is nothing but your spectrum. Okay, at one line you will have amplitude and the other line you will have frequency, and power in dB, okay, can also be measured, where you have 10 log 10, okay, and your PW is nothing but power in watts, and your P dBm, okay, if you have to mention in terms of dB, then it's going to be 10 log 10, okay, power in watts with reference to 1 milliwatt. Okay. Okay, so this is your spectrum analyzer, okay, which I was talking to you about, which is RSA 306. Okay, and the pins available or the ports that we will be using is this 20 dBm port. Okay, this one will normally be for your antenna. I will be showing you how to use it, and then we'll be using an USB 3.0 port. Okay, one end goes into the computer, okay, and this end actually gets connected to the device. So let us just connect it. Okay, so once you connect, you should be able to see a light here. So the other end gets into your one end gets into your laptop, okay, and the other end gets into your device. So once we connect it to the device, the red light will turn green, showing that communication is established. And now for our antenna purpose, what we will do is we will just connect a wire. Okay, as you all are aware, this spectrum analyzer is capable of tuning into frequencies between 9 kilohertz to about 6.2 gigahertz. So it has a broad range of spectrum, right? So now I will show you how to actually get into the software. You have to click. So once you click, this is what you would see. So this is your initial window, okay, where you can see the connection is red, which means it says it is not connected to our instrument, which is RSA 306. So what we have to do is we have certain steps that needs to be followed. So the first thing that I will be doing is, I'll be clicking on live link, connect to instrument. Then this is the code for the instrument, which is RSA 306. Okay, and the port address is also here. So once you click on this, this will start communicating with our device, okay, which is real-time spectrum analyzer. So once it starts communicating, we should be able to see this turning green. So this has turned green, which means there is communication happening between the computer and the device. Okay, right. So as I mentioned previously, this device is actually capable of handling frequencies from kilohertz to gigahertz. So in the range of 9 kilohertz to 6.2 gigahertz. And as I was mentioning previously, these FM signals are also available on your cell phones. But then the reason why we use this spectrum analyzer is because we can analyze each signals, right? We can analyze the power that is taken up and how much time it's taking for the signal to transmit from one end to the other end, and the levels are also taken into consideration. So the main important two ports that I've showed you is the USB 3.0 and the 20 dB antenna port, right? Okay, so here now what we have to do is click on setup displays. So you have a whole set of options here which you will be using in order to view the signals, right? Okay, so here you can select analog modulation, and then you can click on FM. So once you click on FM, this will come up here, which is under selected displays. Okay, and you can press OK. So your blank window will actually start, with the response. I think you can hear, right, that the signals have started coming in, right? So just give me a moment as I tune in. So here you can even see that you have minus 30 dBm, which is a standard that we will be using, and the frequency option. Okay, this is where you will be tuning in to any frequency. Okay, and you will be able to hear the signals, right? Now the other thing that we can also check is that you will have run option. Okay, so click on run, and when you say continuous, the signals will start continuously, right? Now here, if you can see, there is peak. Okay, I hope you can hear the signals. This is how you'll be able to hear the output, okay, from your spectrum analyzer from the interface. Okay, when I go into run continuous, so these are live signals. You can even change the frequency as I'm changing right now. So these are live signals which actually comes in. Okay, this will be the output for your experiment. Okay, so we have an option called marker in order to check the peaks. Okay, and I will show you how to use this marker option. So as I was mentioning, you have these options here. Okay, where you have something called marker. Okay, and I can select peak. Okay, so once I select the peak, I was mentioning to you about the MR, which is nothing but the maximum resolution, right? So this is what you can see, your maximum resolution. Okay, so this will select the peak values, and you should be able to see those values. Okay, so this is how you actually analyze your signals, and you can extract more details from a particular signal. If in case these options here are dynamically changing, so you can click on run single. Okay, so once you click on run single, these options will all be these parameters will all be stable, and it will be easy for you to trace it out. Okay, the other thing that you can also do is you can view the spectrum, right? So that's the reason we are using it. So again, we get back to setup, displays. Okay, then we can get into measurements. Okay, under measurements, general signal. Then here we can also click on spectrum. Okay, double click on it, so it comes here. Similarly, I would like to see something with regards to frequency versus time, and probably the spectrogram. Okay, so all these options, once you double click, these will come down, and when you click OK, okay, you should be able to see these signals. Now this should be in continuous mode. Okay, now since it's in single, you will not be able to see these values in dynamic, so it should be in continuous mode. Okay, so you can see that these signals have started, and the spectrum has also started, right? You can see the signals, and you will be able to see a lot of values. Okay, as I mentioned, okay, you will have a lot of values where you can actually check what is the center frequency, the start frequency, the stop frequency, then how much step size that you are going to give. Okay, then similarly you have in your spectrogram, you have something called RBW, which is nothing but your resolution bandwidth. Okay, so this can happen towards the vertical line as well, right? And yeah, so this is your VBW, which is vertical bandwidth, right? So this also can be selected, and you will also find something called maximum resolution. Okay, so many such parameters can actually be taken into consideration when we get into setup, displays. Okay, and the options that we select. Okay, so this is about your spectrum analyzer. So the reason why we are using this is because we can analyze each signals, right? For example, now I want to just check only the spectrum in detail, so I can maximize that window. Okay, now that I have stopped it, okay, so the signals are all stationary, right? And I can actually click on run, so you can see that the signals are all dynamic, right? Okay, so in order to get these details, we will have to look into each window particularly, and we can actually get more specifics. Similarly, your spectrogram, right? When you maximize, you can see a lot of data here, how many times per division, then what is your RBW, then VBW, then your center frequency, okay, your bandwidth. You have a lot of options to look into, a lot of options to actually monitor. You can even monitor signals. The Bluetooth signals also can be monitored using this spectrum analyzer. So there is n number of applications that can be used. As I mentioned previously, the applications are plenty, right? The applications are plenty.
The only thing is how best we make use of these, right? I have just mentioned that it is used for academic purpose, but in academic purpose, you can even use it for projects. You can use for analyzing various signals, right? And it can be used for the purpose of maintenance, installation, and repair in various factories involved in telecommunications, right? So ultimately what we are doing is, if you can see this block diagram, right, the signals can be displayed using an LCD or CRT display. But right now, since we are using a laptop, right, so those signals are directly seen on our laptop screen, right? Okay. So all this we had seen as to how it comes into. And few more parameters that you can actually look into is there are about 27 spectrum and signal analysis that can be done. Okay, so as I mentioned, WLAN, Bluetooth, all these can be measured. Okay, then this happens in real time. Okay, these are real time signals. So which means the analysis that happens is in real time. And if in case it's used in the field of telecommunications, then real time feedback gets, uh, gets generated, and this can be used by the service providers in order to enhance their networks, in order to enhance their spectrum allocations, right? Then you have various APIs which actually helps in getting these uh, you know parameters analyzed. Okay, APIs, as I mentioned to you earlier, is nothing but your application programming interface. And still, if you want to get into a lot of details, you can actually install the toolbox in your MATLAB, and various other parameters can be analyzed. Okay, thank you.